Okay, everybody. This is our first lesson for statistics. Everybody's got our new book, and the first lesson is on the concepts mean, median, and mode. If they sound familiar, it's because, I want to say they're in the grade 8 curriculum, so you haven't seen them in a while. But they're not that tough. Take a look where it says lesson 1. We'll read some things together here. Statistics are used in everyday life. They are used to predict weather, figure out insurance premiums, and show the abilities of athletes. All data that you encounter is based on statistics. However, this data may have skewed or half-truth conclusions. Depending on what kind of information the user wants to pass on. You will be dealing with measures of central tendency, a value that represents the center of a set of data. In this unit, or measurements based on the center of a group of data. The word average is often used in everyday language to describe the sum of a set of values divided by the total number of values. In statistics, this term is known as the arithmetic mean. So most of the time when somebody says, well, what's the average? You probably just think, oh, I'll just add up how many things there are and divide by the number of things. That's good, but that's not the only way to calculate an average. That one specifically in mathematics and statistics is, again, called the arithmetic mean. And the symbol for the arithmetic mean is this letter X with the bar over it. It's kind of like that bar you used to put on repeating decimals. You put it on the X. In fact, most people in statistics, instead of even saying mean or saying average, they'll say X bar. What's the X bar of that data? Which is a fancy way of saying, if I added up all the numbers and divided by how many numbers it was, what would I get? And you're probably thinking, couldn't you just say average? Well, that's not the only way to do average. So we kind of avoid the word average unless we're really sure we know what we're talking about. So the arithmetic mean is the sum of all the values divided by the number of values. There are two other common statistical terms that are used to refer to the center of a set of values. And again, both of these things could also be used as averages. The median and the mode. The median of a set of values is the middle value when the values are arranged in ascending, that means from smallest to biggest, or descending order, that means from biggest to smallest. If there's an even number of values, you must average, oh, there's the A word, that means add them up and divide by 2. You must average the two middle values. Finally, there's the mode. The mode of a set of values is the value that occurs the most often. Note that if the values occur with the same frequency, then there is no mode. Also, if two values have the most frequency, then they're both modes. Finally, there's this concept here, the range of the data. The range of the data tells you the upper and lower parameters of the given data. Therefore, you would want to take the highest score and subtract the lowest score. So there's a little formula for you. Range equals highest minus lowest. So let's do some examples. There's a nice set of data right there. Calculate the mean, the median, the mode, and the range for that set of values. So how do I calculate the mean? Well, to calculate the mean, okay, I got to flip my screen over here. Yeah, there we go. Oh, so hang on, something bad happened. Uh-oh, I'm probably gonna have to restart my video. Let's see, are we still recording? Let's see.
Yes, you are.
Yeah, we're still going. Okay, I don't know why the screens all went weird, but we're still on. Okay, so the mean is add up all of the data points. So all of these things added together. That's a plus sign. And then divide that by how many points it is. So I'll count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So divide by 9. Okay, I'm going to have to use my calculator for that. So my calculator for that, let's see, where's my, oh, I think I have this here someplace. There we go. So let's see, I end up with, oh, I don't actually have the answer, I just have the final answer. Oh, well, I'll punch buttons. So 55 plus 78 plus 70 plus 77 plus 62 plus 78 plus 39 plus 45 plus 72. Okay, somebody punch with me, and do you get the same number as me on top here? Is that what you got too? Okay, good. And then we divide that by 9. So divide by 9. And there we go. The mean of that data is 64. So say that this was test scores in a class of 9 students. The average, I could say confidently, is 64, but I should also say that's the mean average, the arithmetic mean average. Median is where I take my numbers and I line them up. I'll go from smallest to biggest, but it actually doesn't matter what order you do. Okay, what's the smallest number here? I guess it's the 39. So I like crossing them off as I go. What's the next one? I guess it's the 45. And then after the 45, maybe the 55. Then it's the 62. 70. Well, I can't go that fast. 72. 77. And then there's two 78s. Yes, I have to put them both. They count. They're both data. Now, I've lined up 9 numbers. Where's the middle? Yeah, you can do that. That's a very good way to do it. You can just put your finger here, and then move one space each time. So you'd go that way, and then dun, dun, dun. Now, obviously, if you had a list of hundreds of pieces of data, you probably wouldn't want to count with your fingers like that. So there is, of course, a more scientific way to find the middle place of 9 things. 9 divided by 2, and then round that number. So that would be 4.5. If you round that, you get 5. So therefore, the 5th place is the center. Now, can I point out to you, it said in the notes a minute ago, what if there were 10 data points? Then there'd be 2 numbers in the middle, and you just add them up and divide by 2. So that's it. That's the median. And I could also say that the average of this data is 70, because 70 is the number that's right in the middle. Half of the data is smaller, half of the data is bigger. So there we go. That's median. Next, mode. Mode is the number or the value that happens the most often. Not every data set has a mode, but this one does. Notice, well, I kind of scribbled on it. Here, let me erase my scribbling. Notice that there's actually only one number that happens twice, 78. So 78 is my mode. And oops, that's supposed to be happens. It happens twice. Now, what if there was another number that happens twice? Oh, then there's 2 modes. Now, it's a weird thing to think, would somebody actually call that their average? They might. Let me give you 3 examples. Probably the most common example is, you know when mean is the best time to do your average, to use as your average? Mean is the best when your data isn't really widely spread apart. Like, for example, again, what's the average mark in a class on a test? I would probably just add them all up and divide, boom, there's the average. But suppose that I was doing something like, what's the average salary of the hockey players on a professional hockey team? Well, here's the thing. Doesn't every professional hockey team, especially at the NHL level, have a couple guys who make all-star money, and then the rest of the team doesn't make anywhere near that? So I'm talking about money. So if for example, let me just move over. If, for example, let's say that my hockey team only had 5 players, and one player made $100,000, and the next player made $150,000, and the next player made $200,000, And then the fourth player made $220,000. But the fifth guy is my all-star. He makes $10 million. Do you see the problem with a arithmetic mean? What is the problem? Yeah, if I add these 5 numbers up and then divide by 5, I'm going to get a number that's closer to this number and nowhere near the other 4. So it's not a good thing to say that's the center of my data. After all, mean, median, mode are again called measures of central tendency. How does the center of my data tend to behave? Well, what good is this number if it's nowhere near the center of my data? So it's probably better in this case to use a median. Which player is in the middle? Half the players make less, half the players make more. I guess it'd be this guy. There, that's a better average salary for this team of professional athletes. It's no point in saying, well, my average athlete makes $9 million, because that's about what I'd get if I added these 5 numbers up and divided by 2. I only have one guy who makes anywhere near that, and he makes a bit more. See the logic on that? So sometimes it's better to use median for your average. When would you ever use mode? When would it ever make sense to say, oh, my average is just the number I see the most often? How about if you were in charge of a shoe store and somebody wanted to know, what's the average shoe size? That's supposed to be a shoe. Well, most people have maybe a size 8 or a size 8.5. Would it make sense to add up, okay, this guy bought an 8.5, the next guy came in and bought a 9, the next guy bought a 9, the next guy bought a 10, then some giant came in and bought a size 14. Should I add all those up and divide by whatever number of people bought shoes today? That doesn't make any sense. I might end up with something like 9.75. I don't even have that size. How could it be my average shoe size? I could, but still, does that represent the center of my data? Not really. The center of my data in this case is the number that happens the most. So the average shoe size would probably be best represented by my mode. What one do I sell the most of? Another thing you can do with mode that you can't do with the other two is do an average of things that aren't numerical. Suppose my data is blood type. First guy comes along, he's blood type A, and then another A, and then a B, and then an O, and then I think that's it, right? That's all the blood types, A, B. Oh, no, and then there's AB. And there's an AB comes in. Well, what would be the average blood type? Anybody know the average blood type? In this case, it'd be the mode. I think O is the most common blood type, right? Am I right about that? I don't know. You biologists can figure that out. But there you go. What would it make? You can't add A's and B's and AO's or AB's and O's and divide. It doesn't make any logical sense mathematically. But I could say my average blood type is the one that happens the most. So mode can be used as a measure of the center of my data. I can, under the right circumstances, call it an average. So that's my 3 measures of central tendency. This guy is kind of different. This range isn't really a measure of the center of my data. It is a measure of, fancy word here that I'm not sure I can spell. It's a measure of dispersion. I think I spelled that word right. In other words, it's a measure of how spread out my data is. So what's the range again? They gave me a formula. It's take the biggest number in my data minus the smallest number in my data. So the range of my data is 78 minus 39. Those of you who remember from grade 10 MEAP, or you've been doing some pre-cal or applied courses, range means the same thing here that it does when you're talking about y-intercept or y numbers on a graph. It's the smallest thing, and it's the distance between the biggest and smallest numbers. So what's 78 minus 39? That's going to be, well, let's see, 78 minus 39. I'll take my calculator. 78, whoops, 78 minus 39 is equal to 39. So that's my range. Okay, let's take a look at example 2. Hank has a mean mark of 50 for his first 3 math tests. Then he earns a mark of 70 on his 4th math test. Hank states that since the average of 50 and 70 is 60, his new mean math mark is 60. Do you think Hank is correct? Well, here's the way I would approach this. After 3 tests, I would say, of course, that my mean is always the same formula. It's the sum of all the data points divided by the number of data points. And for his first 3 math tests, he has a mean of 50. So 50 is the mean, and he wrote 3 tests. And I've said this many times through the course, we don't do much algebra, but it pops up every now and then. How do I figure out what the sum of his first 3 tests are? What would isolate sum? Multiply both sides of the equation by 3. That's exactly right. So I'm going to times both sides of the equation by 3. So 150 is the sum of the first 3 tests. Now, I don't know how much he got on each individual test, right? Maybe he got, maybe he got 75, 75, and 0. I don't know. All I know is that the 3 tests add up to 150. And that's all I need to know. Because what happens now is, after test 4, I can say that the mean is again equal to the sum divided by the number of things that we're adding. And I don't know this mean, but I now know that the sum is this sum of the first 3 tests plus my new test that I'm quite proud of, assuming I'm Hank. But what's the bottom now? Now I have used 4 tests, right? So the mean after 4 tests, now Hank said that this should bring my average up to 60. Is he right? Well, let's see. What's 150 plus 70? You can use your calculator if you want. 220 divided by 4. What's 220 divided by 4? The answer is 55. Therefore, Hank is incorrect. His new average is 55%, not 60%. Because if all 4 tests carry the same weight, one test doesn't equal the same weight as the other 3. So there we go. That's the basics on mean, median, mode, and range. So we'll end our little lesson there. For the people who maybe missed this, or maybe as it gets closer to test day, you could watch this lesson again. It'll be on the blog. So I'll end my video there. Thanks for watching.